Let me tell you about this time that we solved the problem of the big flood in our factory. Hello, I'm Tom. Welcome to my channel where we talk about continuous improvement in an industrial setting. And today I'm going to talk you through a case study of how I used the 6-step problem-solving method to solve quite a dangerous problem in one of our factories. Now let me set the stage a little bit of what was happening. Say we had this production machine. I'll not go into too much of the details also to save which factory this was, but suffice to say that machine needs to be cleaned from time to time. And what we saw is when you're cleaning the machine, it's a top cleaning, it will drip through this whole block where there's all kinds of parts that are usually moving around and they're getting a bit dirty. It drips down into this collection tray underneath. Then the water or cleaning water flows to sort of an extra small tank where it is pumped away back into our CIP system or in certain phases down the drain. Now what was happening is that it was not pumping away quick enough, or at least what we saw happening was that water would overflow. Now why is it such a problem? If it would have been just water, it would still not be nice, right? You don't want any cleaning water running over the floor, but this is during an industrial cleaning cycle. So there is also a caustic phase and there is an acid phase, and this water is boiling hot. So this is a serious safety risk. It gives off fumes that will be in the whole area, but more importantly, when this is on the floor, that is just a hot caustic mess. That is really no joke. You cannot safely be in that area. So this was a huge problem. Now, what we did at the factory already for some time, because this problem popped up about 2 years before my team was flown in to help also solve this problem amongst other continuous improvement efforts that we did there, is that they would just close off the whole area during cleaning to keep people away from this hazard. And yeah, if your concern is safety, that is definitely a good way to solve it. But of course, we had not solved the problem yet. And when we started up our problem-solving methods, our problem-solving tools at this factory, the production manager also really asked us, please take a look at this problem, because we've been looking at it before and we cannot figure it out. Take some people into the team, will free up the resources, but please also provide from your side, the methodology and the way of critical thinking, because this is a serious thing. We don't want to fully redesign this machine yet, because that's very expensive and it is the heart of our production process. It makes the products that we love here. So we're in this catch-22. Can't change it, but can't really continue like this as well. So we formed a team with an engineer and a team leader. There was also a facilitator, of course, and someone sort of a programming engineer, right? So someone who can program PLCs and is really good in all of the software that controls everything, the flows and the phases and that whole part of the project. And with them, we got that clear problem, it's overflowing, big safety hazard. Then we went on to defining what really happens. So the problem definition, for which we use this what, when, where, who, which, how, and how much, so the 5 W's and the 2 H's, and we pair that with an is-IsNot analysis. Now, the one we did was a bit more elaborate than what I'm putting on the board here. And I'll just take you through a couple of the highlights. And the basic things, what we saw is that, it's in every CIP, cleaning in place. So every cleaning basically has it, although when we do a changeover rinse, which is sort of a quick system, we did not see the problem happening like that. But if you do a full cleaning, you get the problem. That might also be linked to that we didn't really see it in the first 10 minutes, but about a minute after the start of the main cleaning phase, it would start to overflow. So we know already there is something with maybe the timings or the different flow rates. We also we checked the flow rates, and we know that there was a change in the flow rates about 2 years ago, also when we really started seeing this problem, although operators did tell us it might have gotten worse, but already before we made that change, already before 2 years ago, we also would have small puddles. So the problem has gotten worse, but is not new. Very important information. Now, what did we see? It was about 2 cubic meters of liquid that were going over the floor, and we could measure this by the in and out flows and stuff like that. So we did quite a bit of what is happening. We also did, with good safety equipment, go into that area, install some cameras, made some videos from further away, but also installed cameras that could really get some footage of what was happening during the cleaning and during when the problem occurs. And we saw, some lower areas of this tray, they would overflow. And also it's as if this pump cannot handle the inflow of water. So at some point, this one starts overflowing, and that one sometimes also a bit. But it was mainly in the small tank. This pump apparently could not handle the inflow coming from here, and also we did see it build up here. So by that you already know that there's a couple of problem points. This here is almost certainly a problem point, because otherwise it would at least drain all down. And here we've got a new problem point. At least that's what we thought. In fact, the answer, well, this one was correct. This answer, a bit of a spoiler, will be changed in a bit, because actually that one was fine. Now, we put some temporary control measures in place. We kept closing off everything. We heightened the tray a bit so that it wouldn't go off there. And already quite quickly we knew that we had to do a change here. This flow had to become bigger. We put it on the list already. We put it on the countermeasures list, because we knew this had to be installed. But if you change something here, you have to change so much that we went into the analysis phase as well. Now, in the analysis phase, we were not happy with what we saw, of course. We knew that we had the problem defined quite well, but something just wasn't right. So are these pipes blocking? Are the flow rates maybe not good? So we checked the incoming flow rate, was basically the same as the outgoing flow rate in the beginning, but then the outgoing flow rate dropped. So there was already a problem. Now we knew that the flow rate of the cleaning liquid was increased 2 years ago, so that's one of the temporary controls we also did. We put it back down and made a slightly longer cleaning. Didn't help a lot though, but it did prevent at least this spillage. Maybe, the valves are closed or the pump is not steered correctly. And when we kept analyzing all of these points through a number of cleaning cycles, what we saw is that, the tray, it's basically okay if this one is wide enough. And by this time we installed a wider exit, then it did overflow a lot more in this small vessel. The flow rates, yes, but honestly, this pump could easily pump away the flow rate we are putting in as cleaning. So it helped a bit, but that wasn't the one. And also how it started pumping, that was okay. The valves, we did make a small change. There is a second pump actually going out of here. We also rerouted that so that we had absolute over capacity in pumping it away. So we did do a bit with which valves are closed, which are not, but this was not a problem by the operator, this was by design. Now, in the end, when we were making, for the so manyth time, video of what was happening here, what we saw was that the water flow started this circular flow that was basically jamming itself. So because you have a circular water flow, it did not go into the pumping house. So this here created this big circular thing, reducing the outflow. And once we got that, we knew that we had to do something, not just widening this pipe, but we made the pipe go into the vessel in not in the center, but in a bit of a round way, and basically installed the in and outlet pipes so that the flow pushes itself into the pump house. Could that have been done by engineers 5 years ago? Yeah, probably yes, but this is one of the things you don't think about all of this. You don't see all of those problems. And when 2 years ago they made a change that was completely different from the root causes, the problem got a lot worse, but just going back with that change didn't solve it. And by really going through all of these steps, we managed to find, and really this frustrated from time to time as well, because there was sort of a blockage, but not in the pump. We opened up everything. We really checked, the pump was good, the pipes were good. There was sort of a blockage, but it was a flow blockage. It was really because of what the water was doing itself, not any physical blockage of the pipe, but a physics blocking of how the flow was. And once we found that, well, then the countermeasures were quite easy to install. Now, a nice thing of this change also is that to sustain this change, it was a very technical change in the process. So once we had that done, we of course documented what happened, why it happened, what we did, why we made these changes. So we made good documentation for, maybe in 5 years when they want to do something again with these valves, and also because that factory is actively designing the new version of their own machine. So this needs to be taken into the design of that new machine. But those are, that's more the documentation side. For the operator, their way of working didn't really change. The only thing we could change is that we don't have to close down this area anymore because it's now safe to be there during cleaning. Well, even if they do still close it off purely by habit, not a big problem. But this is such an easy change to sustain because you make life easier for anyone working there. So basically our sustain phase was very, very easy. But we did put in place a couple of checks, just the in and out flows, put it in documentation, make sure that we also had a couple of evaluation moments after 3 months, 6 months, 12 months, just to check, is everything still working fine? And I'm happy to report that up until this day, things are solved. So taking away the root cause to prevent future failure really worked in this problem-solving case. Now, if you also want to solve problems in this way, download my free 6-step problem-solving template and continue your learning journey on problem-solving. It is a truly important thing to have in any organization, and that means that you yourself will also become a lot more valuable to your current or future organizations when you learn how to problem solve in a good way involving the teams. For now, I wish you the best of luck with your problem solving, and as always, don't forget to enjoy the continuous improvement journey.